Hello everyone, welcome back. So this is the fifth lecture of our linked list for interviews series, and in this video we are going to look at the problem linked list cycle 2. According to the problem statement, we are given the head of a linked list and we need to return the node where the cycle in that linked list begins. If there is no cycle, we need to return null. So it states that there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. For example, in this linked list, if we keep moving to the next node, if we keep following the next pointer, so from this node with value -4, we can go back to the node with value 2. So as this node can be visited again, which means that there is a cycle in this linked list. Okay, and we do not have to modify the linked list. So this was the problem statement. Now let us see the approach to solve this problem. In order to find the starting node of the cycle in our linked list, we have divided our task in two parts. Firstly, we will identify whether the cycle exists or not, and if the cycle exists, then we are going to find the starting node of that cycle in our linked list. So these are the two main things that we need to do. Coming to the first part, in order to identify the cycle, we are going to use two pointers. So here I have initialized a slow pointer and a fast pointer. So basically slow pointer will move ahead one step at a time and fast pointer will move ahead two steps at a time. So we can say that speed of this fast pointer is twice the speed of the slow pointer. Okay, now let me walk you through this, how it's going to work. So in the beginning, our fast and slow pointers are pointing to the head of this linked list. Now we are going to begin iterating our linked list. So slow pointer will move to the next node one step ahead and fast pointer will move two steps ahead. Okay, now again slow pointer will move one step ahead and fast pointer will move two steps ahead, so it will come here. Now again slow pointer will move one step ahead and fast pointer will move two steps ahead, so it will come here. Now again slow pointer will move one step ahead and fast pointer will move two steps ahead. Fast pointer will move two steps ahead, it will come here. Now as you can see, fast pointer was moving twice the speed of the slow pointer. So obviously in the beginning it was way ahead than the slow pointer. But if there exists a cycle in our linked list, then it means that there will come a time where our fast pointer will come behind the slow pointer. If this linked list was a linear linked list, what would have happened was fast pointer would have reached null, and if our fast pointer reaches null, we can say that there is no cycle and we can return null. If there is a cycle, then there will come a time when our fast pointer will come behind this slow pointer. Okay, so as here we can see that fast pointer is now behind the slow pointer, we can say that yes, the cycle exists, but in our code this much is not enough. We need some condition to say that yes, the cycle actually exists. Here we cannot detect how fast pointer is behind slow pointer. There we cannot guarantee it. So what we'll do is we will continue this process. So slow pointer will move one step ahead and fast pointer will move two steps ahead. You can see that fast pointer is now behind the slow pointer because there is a cycle. Now slow pointer will again move one step ahead and fast pointer will move two steps ahead. Now As you can see, both fast and slow pointers are coinciding at a particular node. It means that they have met at a particular node. So whenever our fast and slow pointers meet at a particular node, we can say that yes, the cycle exists. So this is the condition. Whenever these two pointers meet at a particular node, we can say that the cycle exists. The reason being is that the fast pointer was moving 2 steps ahead, which is twice the speed of the slow pointer. So it should have reached null if it was a linear linked list. But instead of reaching null, it coincided with the slow pointer. It means that there was some cycle in the linked list, and after taking some rounds in that cycle, both these pointers met together at this node. Hence, we can say that yes, the cycle exists. So now that we have identified the cycle, our task is to find the starting node of the cycle. In order to do that, we need to understand few basic things. So let us consider that the distance from the head of the linked list to the starting node. So this is our starting node, right? And we need to identify it. So let us say that distance from the head to the starting node is L1, and distance from the starting node to the node where the two pointers have coincided, let us call this distance as L2. Now as slow pointer was moving 1 step ahead and fast pointer was moving 2 steps ahead, we can say that distance covered by fast pointer is twice the distance covered by slow pointer, right? Fast pointer was moving twice the speed of the slow pointer, because of which we can say that distance covered by fast pointer is twice the speed of this distance covered by slow pointer. Now what will be the distance covered by slow pointer? So it will be L1 plus L2, right? So distance covered by slow pointer will be L1 plus L2. We are not actually concerned with the real distance covered. Here L2 is basically the distance between the starting node of the cycle and the coinciding node where the two pointers coincide. So it is just this distance. Okay. So distance covered by slow pointer will be L1 plus L2. And this, what will be the distance covered by fast pointer? So distance covered by fast pointer will be at least be the distance covered by slow pointer. Okay. So that distance plus, as it is moving twice the speed of the slow pointer, there can be a chance that fast pointer takes some rounds in this cycle before it meets the slow pointer at this node. So L1 plus L2 plus it can take some rounds in this cycle. So let us say that it takes n rounds in the cycle and the length of the cycle is c. Okay. So distance covered by fast pointer will be L1 plus L2 plus nc. So it will cover at least the distance covered by slow pointer plus it will cover some rounds in the cycle and the length of the cycle is c. So we got this expression. Now if we simplify it, we are going to get L1 plus L2 equals to nc. Okay. So I hope this much was clear. Now here the thing is, n is the number of rounds taken by the fast pointer. Now n is going to be a constant, so we can ignore it because we are only concerned with the distance between the nodes. Okay, and we don't actually need to find the total distance covered by the fast pointer. So we can ignore this n, which is the number of rounds covered by the fast pointer. So our expression will be L1 equals to nc minus L2, which means that L1 equals to NC. So if we ignore N, if we simply ignore N, we have C minus L2. If the total length of the cycle is C, if if this length is C, so C minus L2 gives us this length. So this length is C minus L2, right? So at the end what we have here is L1 equals to C minus L2, which means that this L1 distance is same as the distance between the starting node and this coinciding node. So in order to reach to the starting node, and what we can do is we can take a pointer temp at the head of this linked list. We can take the pointer temp at the head of this linked list, and now we are going to do is we will move slow pointer at this from this coinciding node and temp pointer from the head of the linked list, and both the pointers we are going to move one step ahead. So we will move temp one step ahead and slow pointer will also move one step ahead like it was already moving. Now again temp pointer will move one step ahead and slow pointer will move to the next node. Now the node where these two pointers meet is the starting node of the cycle. Okay, so this is how we are going to find the starting node of our cycle. And once our fast pointer and slow pointers coincide at a particular node, we are going to take a temp pointer at the head of the linked list and we are going to move temp pointer and slow pointer one step ahead, and the node where these two pointers meet, slow pointer and temp pointer, that node is going to be the starting node of our cycle in the linked list. So this was the algorithm, and this algorithm is popularly known as Floyd's cycle detection algorithm. Okay, now let us move to the coding section to see the code of this algorithm. So we are going to see the C++ code. So we are given the head of the linked list. So firstly we are going to check if the head is null, it means that there is no linked list, we are going to return null. Otherwise I have initialized two pointers, slow pointer and fast pointer, both pointing at the head of the linked list, and we are going to start iterating through our linked list, and our terminating condition would be when our fast pointer reaches null. So whenever our fast pointer reaches the end of the linked list, it means that the given linked list is linear, and hence we are going to return null. So our slow pointer will move one step ahead and our fast pointer will move two steps ahead. So here we are doing fast, next, next, and if there comes a moment where these two pointers coincide at a particular node, so if slow pointer becomes equals to fast pointer, it means that yes, the cycle exists. So from there we are going to execute our second part of our algorithm. We are going to find the starting node. So for that I have initialized another pointer temp at the head of the linked list, and while temp is not equals to slow, we will keep moving both the pointers one step ahead. So temp pointer will move to the next node and slow pointer will move to the next node. We will keep doing this, and when temp pointer and slow pointer both coincide at a particular node, we are going to return that node. That node is going to be the starting node of our cycle in our linked list. So this was the algorithm, and if these two pointers never coincide and fast pointer reaches null, it means that the given linked list contains no cycle and we can return null. So if I try to submit this, so as you can see the code got accepted. So this was the approach to solve one of the most important problem on linked list. So make sure you practice it well. This was it for this video. If you are new to the channel, please consider subscribing and also share it with your other friends. Thank you and have a nice day.